to get started with our Master Speaker Series event for tonight. So with that, I'd like to welcome everyone to the September Master Speaker Series event for Worth Ross. My name is Matt Kopchak, and I am the Vice President of Management. For those of you that are joining us for the first time, welcome tonight. We designed these exclusive events to bring industry experts to the forefront, giving you all as attendees an uninterrupted experience like no other. And thank you everyone who has joined in the past for joining again and continuing to join in these virtual presentations. Throughout the night, we hope that you will gain some valuable insight, learn about best practices, and have the opportunity to ask some questions at the end. We carefully selected our Master Speaker Series attendees, our panelists rather, who are familiar with the specific needs and challenges that our association boards and managers are faced with. So before I introduce our panelists for tonight, just a couple housekeeping items. A reminder, just like events in the past, this presentation tonight is being recorded, and we will make it available to everyone who attended, and even those who weren't able to attend. It'll be available via video, probably later this week or early next week. We just want to ensure that all of our board members and our team have the resources they need in order to best lead their communities. And with that, we will go into today's topic for our Master Speaker Series, and it is UV lighting, air, and surface disinfection. So with me tonight, we have Charles Hansford with 4L Engineering and Bob Mitchell from Worth Ross. The topics for today's discussion and presentation, we're going to provide an in-depth review of the newest sterilization protocols of air, surfaces, and UV lighting. More specifically, those items as it relates to association living. So the format for this evening will be similar to the last one, the event we had in August, which will be approximately 40 minutes with a presentation between Bob and Charles. And then after that, we will have a Q&A. Some of our attendees have submitted questions ahead of time, so we'll go through those. But as the presentation goes on, if anyone has questions this evening, you can chat them to me, Matt Kopchak, in the chat box, and I will bring them up at the end if your question has not already been addressed throughout the evening. With that, I'm going to turn it over to Bob and Charles. So go ahead and take it away, gentlemen.
Good evening, everybody. I'm Charles Hansford with 4L Engineering Company. I'm going to do the first part of the segment by covering different areas of implementing measures to minimize the risk with infection in your homes and in your buildings. Next slide. You know, in the past, our design goals were very simple in doing HVAC designs in buildings. We had simple controls. We just had a thermostat, easy to adjust temperatures. We paid a little bit of attention to air circulation or air movement through the space. We looked at filtration a little bit, but basically it's just to filter out the big pieces. We worried a little bit about odor dilution by bringing in outside air. It had to operate fairly inexpensive, and it had to be a moderate cost. Next slide. But today we're faced with a new problem. With this virus that's going around, we have new hazards that are going to change everything that we're going to do in the HVAC industries. And we're faced with all types of viruses, bacteria, movement. It's going to cost more money to place things into place. It's going to cost more to operate. Next slide. We see the problem with humans that breathe and talk and sing and cough and sneeze. And they exhale all of these vapors that tend to radiate out. We also get vapors off of toilets that people may not realize, especially if we have a high-rise building that has what we call a solvent plumbing system. We're having problems with medical procedures in dental places and also in doctors. Next slide. When we emit these particles, they move at a certain distance. If we just got moderate talking, sometimes we just spit a short distance. If we cough, we're going to throw it a little bit further. And if we sneeze, we can hit the other side of the room. Next slide. Here sort of demonstrates the distance that droplets go. When we exhale or blow the debris out of our mouth, it usually drops at around 5 feet. They tell you that 6 feet is a safe distance, but if you really understand what's happening with the spray under a heavy sneeze or a heavy cough, it can actually travel up to 19.7 feet. Next slide. This airborne droplets, they drop on surfaces. You know, they talk about the life expectancy of some of this. These droplets, the airborne stuff only lasts like 3 hours, but the stuff that comes in contact on the floor and on surfaces can last up to about 16 hours. Next slide. So some of the things that we need to be looking at is we're going to change some of the parameters with temperature and humidity control inside our spaces. We're going to start worrying a lot about ventilation. You're going to hear a lot about that. You're going to hear about pressurization inside the space. So we're going to bring in air into our space so it tends to leak out of the cracks in the building rather than leaking into the cracks. We're going to talk about air distribution and the way we distribute the air through the room. And more importantly, we're going to really dwell on filtration. And then we're going to talk about some areas of disinfecting. When we talk about temperature in a room, typically if we're designing a space, our temperature ranges in the summertime would run 74 degrees plus or minus 2 to like 50% relative humidity in the space. And in the wintertime, we'd get down to around 72 with about 15% relative humidity in this space. And that's without what we call humidification. And this is typically where everybody operates. Next slide. Temperature is the easy thing to control, but humidity is the problem. Remember that with humidity, we have problems with materials that's in the space. Wood, flooring, artwork, wall texture, baseboards around the edge of the floor, and with lack of moisture, these things start to separate. Also, for people that tend to walk around a room on a carpet, sometimes they can walk over and touch a doorknob, and they get shocked when they shuffle their feet across the carpet in the wintertime. And finally, the big thing is human health and comfort by controlling humidity. When we look at this, our body's made up of 65% water. The thing of it is, if we look at the optimum range for controlling humidity, it is somewhere between 30 to 60%. Remember that most of your systems are operating as low as 15% if you're in Dallas. And here's some of the things that can be affected. The virus, respiratory problems, dry noses, things like this. So if we can bring the humidity up, we can minimize some of those problems. We're fixing to move into the cold season, so we can have a big effect there. If you look to the right of the chart, there's some things that dwell at higher humidities. And you'd never want to go above about 60% relative humidity in any space. But if you get above 60%, you may want to consider that a device that's called dehumidification. Next slide. Women particularly understand the problem. They always have hair problems with lack of humidity. It increases the risk of health problems with high humidity. We have discomfort, we have dry noses, eye irritation, things like this. So these are some of the things that we're trying to control. And so again, we're trying to move this thing. If you need some of these problems solved, it's sort of like I can kill 3 things with one purchase. By controlling the humidity in the wintertime, I help your health. I improve the life expectancy on your wood floors and the separation you have, and also minimize static electricity. Next slide. Air distribution is a problem. Here we have a air conditioning unit over to our left-hand side in the first slide right there. And we have a filter on the face of it on the lower part right there that brings the air across the filter into the unit, distributes it through a grill into our room. And that would be our primary air that's blowing into the room across the blue area that you see there in the picture. As that air moves around, it induces secondary air out of the room, which sort of stirs up some of the particles that's in the room with your primary air. Then everything moves back to a return grill down at the bottom side. And there you'll see that I bring it through a return grill into a sort of a boxed in area there, and also mix it with outside air at that point. Air distribution from the ceiling is shown on the right-hand slide. So we try to cover all areas of a room with this air as we blow it out. In the future, you'll hear me talk about having return air grills on the opposite side of the room so that the air moves one way across the room. It doesn't return back across the room. Next slide. The way we effectively move this air can improve the comfort level in a room. You'll be hearing us talk about air changes. Typically in a high-rise building in a unit, the air changes per hour will be somewhere around 6. We also talk about the outside air changes that we bring in. And typically we will be running somewhere around 1 air changes of outside air. In the future, you're going to see these numbers tend to go up. Next slide. Back in the year 2000, we had a problem with scars, and it generated in China. And what happened, it happened in a Chinese restaurant. A guy at the center table that's marked in red right there, he sneezed at the people facing him in that direction. He had the scars, and he distributed the scars to the people across from him. Next slide. Here you'll see that distributed to the people either side of him there, the people across from him, but the air was moving from the right-hand top of this picture, blowing across the room and returning it back down all the way across the room. So we blew it from right to left, we returned left to right. So as the air was blowing out on the center table, it tended to carry across and caught the people at the back table. And then next slide, as the air returned, it caught a couple of the people at the third table. So here's how ineffective air movement actually distributed scars in this restaurant, which to some degree is the same problem that we're experiencing with COVID-19. Next slide. It is important that everybody has fresh air into their space. We bring this fresh air in for a couple of reasons. Number one, the fresh air that we bring in, and it's usually introduced into everybody's space in some way, unless they close off the damper. And sometimes they'll do that in some buildings because when you bring in the outside air, it's at a higher temperature, and sometimes a higher temperature and a lower humidity, but it adds air conditioning load to the space. So people like to close this outside air off. Don't do it. It's designed to bring fresh air into the space, to eliminate odors that are developed in there, and it's designed to handle that load. If you close it off, what happens now, your unit becomes depressurized to the people on your left or your right that may have their outside air damper open, or the person above you in the upstairs unit, or the one in the downstairs unit. Everybody needs to stay at a fair pressure balance inside these buildings so that if a person has a problem in a center unit, he doesn't distribute it. If he's at a negative space and he doesn't have the disease and the person next door that's pressurized has it, it's going to migrate from the higher pressure to the lower pressure. Next slide. Here's just a little bit of tidbit for people that have residential houses at home. If you have a house at home, occasionally it's good just to open up the outdoor and let some fresh air in by opening or cracking the windows, leaving the door open in moderate temperatures. Turn on your exhaust fans, and it will take probably about 3/4 of an hour to exchange all the air in your house, and thereby loading it up with all new air that tends to eliminate the odors. We also can do this sometimes when we're cooking fish. Next slide. Talk a little bit about filters. Filters is the least expensive thing you can do to control the virus. The thing of it is, filters are very important. They're designed so that as we bring particles from our left-hand side there of the screen, as we blow it across our filter, moving to the right, it collects it on the face of the filter and eliminates the particles downstream. All filters are rated with what we call a MERV rating, which is the minimum efficiency reporting value of a filter. The value of these filters run anywhere from 1 to 20. Next slide. If we look at the efficiency effect of a filter right here, and if you'll look at the MERV 6 there with your pointer, Bob, move down to the bottom right there. Right there at the bottom, you'll see that a MERV 6 will collect particles in the neighborhood of around 0.25, but it only effectively moves, and if you move the chart to the left-hand side of the deal, it only has an effective use of around 10%. If you move up to the MERV 16, at the same number, you'll see that that filter, now when you move it to the left, it has an efficiency rating of somewhere around 0.77 or 75 right there. Next slide. When we look at these MERV ratings that run from 1 to 20, we find that the MERV 13 filter can effectively capture the virus and keep it from being distributed in our house. That means every time that the air passes across my filter, I'm effectively filtering that air and controlling the virus. If you can get a MERV 14, it does a better job. Some people are going to be talking about HEPA filters, which is a high efficiency particle separator. These things are normally in the range of 99.7% efficient, and they take everything out. This would be something we'd use in a hospital. Next slide. One of the things I need to talk about when people start changing their filters, they need to be conscious that, one, your air conditioning unit can only handle a certain grade of filter. And if you increase the MERV rating too high, you're going to drastically reduce the airflow. It's going to catch the particles and the fan horsepower is going to go up. It's important that, one, you sort of search and see how efficient a filter can I put in my unit and it effectively work and provide the airflow that I want, collect the particles that I want, and not exceed the horsepower rating of the fan motor. In the future, you'll hear me talking about ECM motors, which they'll be going away from these 3-speed motors that we're accustomed to seeing in houses. We'll be using an ECM motor that can go up to around 1 inch of total static. One of the things that people should realize is the tightness of that filter in the frame. It should be tight in the filter rack. There should be no gaps that allow air to bypass. It needs to effectively seal. Next slide. Here's a chart that shows that in order to catch, so if I drop down on the virus, which is about right there, and I move to the right there just a little bit, Bob. Right there, you'll see that the virus starts, and if I move up to the top, around 0.1 microns. And so there is where I'm trying to get to try to control the virus. So again, a MERV 13 will reach somewhere into that area. Now, lower grade filters can control some of the other things to my right-hand side. Next slide. Here's what I'm talking about, the resistance of the filter. If you look, if I have a MERV 1 filter there at the bottom of the chart, the initial pressure drop is around 0.04. When I get to 0.25, that is the final pressure drop, and that filter is done. It's loaded. The problem is some of the fans that we use there only have the capability of producing around 0.3 external static. So somewhere before I reach that full loading, that filter will have to be changed. If I move up to a MERV 13 from a MERV 1, you'll see that the initial pressure drop there is 0.39. That is a big change in the resistance across the filter. So again, this is why some of these air conditioning units that we have will not work with this MERV 13. Next slide. Some of the things I can do to improve this problem is typically over there on the right-hand bottom right, I start with a standard 1-inch throwaway filter. It's vertically straight up and down. And it starts with a pressure drop of around 0.04. If I move to the center filter, now here I change from a 1-inch vertical filter to now what we call an extended media, which is a pleated type filter, which has pleats in it that sort of move in and out. That provides us with an extended face area. And my face area on my lower right went from 3.47 square feet to a face area of 5.93 feet. And my pressure drop went to 0.14. By converting from a 1-inch filter to a 2-inch filter, down in my lower left, now what I can do is now my face area now increases to 10.23 square feet, and my pressure drop goes down to around 0.08. So there's some things that we can do for some units by just simply changing the filter rack, putting in a wider filter, we can overcome some of the resistance problems that we're faced with. Next slide. Just remember that when we buy these filters, the price is going to go up. So a MERV 4 might only cost us, on an annual cost, somewhere around $125 a year in this example. And when I move to the right to a MERV 13, I'm going to go from $1.20 there to maybe $1.50 right there. And so as I go on up, then my price goes up. So remember, when we're changing the MERV rating of our filter, we have to first check to see it'll work, see what one we can do. If we can adapt, we do it, and understand that everything's going to cost more. Next slide. UV lighting is something that effectively works to control the virus. And you're going to see a lot of this used to disinfect the airstream in addition to the filter. The optimum range of control, and this is for what they call UVC lighting. The optimum range of control is 265 nms, which is the ideal range. Next slide. We can put these UV lights in our duct system. The big problem with putting it in the duct system is typically that the air has to maintain contact with that light for at least a quarter a second. If we move it too fast, it ain't going to effectively work. We're just going to buy something that's not going to have any effect on us. And typically, in order to do that, we have to slow the air up, which means to slow the air up to around 500 feet per minute, you're going to have to increase the size of the ductwork almost twice what it's typically designed at. And you need to install a minimum of a MERV 8 filter in conjunction with this. Again, if I could use the MERV 13 plus the UV lighting, I sort of double my kill rate. Next slide. We can put this UV lighting on, on the wet side of a cooling coil. It will help control the buildup in the drain pans or any wetted surfaces as far as that goes. You have to set the light so that it evenly shines on the entire face area of the coil. It normally needs to set back off of the face of the coil somewhere around 12 to 36 inches, and you operate it 24/7 or 24 hours a day, 7 days a week. Next slide. Here we can see the UV lighting on the face of a coil, and you sort of look at the shine factor, and they're somewhere around 12 inches off the face of the coil. If you get it too close to the face of the coil, what happens to you is I don't get the shine to cover the entire surface. The second thing is that the moisture, I'm on the wet side of the coil, so the air is moving from the left of that coil to the right. It'll carry the moisture off and hit the light. And of course, I put water onto the light. It's not a good effect. To the right-hand corner here is some of the buildup that exists in drain pans that we control with UV lighting. Next slide. We can also put UV lighting inside the room, and usually at a 7-foot area, and we'll put it around the perimeter of the room or in a covered area that may surround the room, or you can hang it directly from the center, in the center of the room. Remember that UV lighting should not be looked at directly with your eyes because it will affect them. So we have what we have in-room disinfectant. This is the area that the center light covered around the circumference area there. Next slide. It goes 10 feet out all the way around in a radius. There are other types of controls that you can put into controlling this virus. Just remember that some of these things that's listed here, first off, the UVC lighting is really good, and they actually have that so that it can be portable, carried into a room, and use it as a wand to wipe it over surface and sterilize area. Some of the other things that's below there, ionization, ozone, sometimes they can have a good effect, sometimes they can have a bad effect. Remember that one of the lawsuits that occurred with ionization actually put the Brookstone store out of business because they were using ionization to control an area in a room, and that's what caused them to go bankrupt. Next slide. Here is UV lighting around a coved area around the top of our ceiling, covering an area. Here's another picture on the face of a coil. UV lighting into the room over to the right. Actually, some people are using a portable robot to run around different spaces, especially in office spaces, to sterilize spaces at night after everybody's gone. And they'll set that just like they do the mail cart to follow a route and sterilize areas. Next slide. I can't overstress maintenance on anything. First off, remember, always operate your system. You want to keep it operating so that it reduces the stress level on people, keeps the temperature and humidity in line. Change your filters on a regular basis. If you upgrade and you're using MER 13 filters, understand that you're going to have to use some form of PPE. You're going to need to wear goggles, face mask, and wear gloves. When you take the filter out, you need to bag the filter and throw it away at that point in time. Don't shake. In the old days, we used to tell people, take the filter out and shake it. I'm sorry, you're collecting stuff now, and you don't want to shake it. You're just going to put it right back in the room. Check the tightness of the filter in the frame. Clean your cooling coils in the spring. Clean the drain pans in the spring. Check circuit setters or chain strainers. Backflush heat exchangers if you have them. Make sure that the grills are not covered up. Remember, they're there to distribute the air in the room. And so many times people will just take a piece of paper and just cover the grill. And they're reducing the effective throw of the grill to effectively distribute the air. I suggest using pan tabs in the spring and the summer to kill some of the debris that's down in drain pans. Clean the fan wheels in the spring. Test the equipment in summer and winter conditions. Check for condensate leaks. One of the things that we need to be concerned about, if we develop condensate leaks and they start to drip down into areas in our ceiling or on the floor, remember that that creates mold. So when the mold triangle comes into play, that's where we have food, moisture, and air. Air we can't control what's around us. Moisture is coming because of the leak. dirt, is any surface or materials that may be there, that's there. So the thing to do is to control the moisture. Open the windows in moderate weather, flush it out with your exhaust fans. Large buildings, I suggest that sometimes in large buildings, normally in commercial buildings, we'll recommend that they open their outside air dampers and flush the building out with 100% outside air. Slide. One of the things I have to say about toilets, and I might as well give you the potty training right now. First off, when you get ready to flush the toilet, put the lid down before you flush. It reduces the amount of vapors that's coming out. When you're using the toilet, use your exhaust fan, and sometimes even after you flush it, let it run for a little time or even run continuous before you turn it off. Be sure that sometimes if your exhaust fan's blowing outside the window and you got the window cracked, bring in fresh air, be sure that it doesn't just recirculate back into the room. These are some of the services that 4L Engineering Company offers to help our clients. And other than that, I'm going to turn it over to Bob. Oh, wait a minute. I'm sorry, I got two
more, Charles.
One of the things that the CDC came up with was what they call the infection control pyramid. And if we start at the bottom, the first thing that we all started with was just wearing PPE equipment, masks, gloves, gowns, what have you. We then told people what to do and the distance to stand apart, maintain at least 6 feet. Sometimes if people are coughing really bad, you may want to get back against the wall. The next thing we got to do is we've got to control some of these put in engineering controls such as filters, UV lights, some form of disinfecting to go forward. And then the big problem is to try to look to the future, which deals with trying to eliminate the problem in total. Next slide. Remember that as your equipment ends the end of its life, as your equipment approaches the end of its life, we usually have a reserve study, and what we're doing is we're simply replacing the equipment with the same piece of equipment we had to start with. But I think one of the things that we have to do is we have to change the way we think. Is there something that we can do to improve the control of some of these viruses inside our building? It may be we can buy a bigger unit sometimes. We could buy a unit that'll handle extra filtration. We could buy a unit that actually comes with UV lighting if we wanted on it. buy equipment that has what we call an ECM motor. And you'll hear me really stress that. It has the ability, and the reason it was created was really for equipment manufacturers to not have to pay so many claims for warranty for compressors going out. And the claim was really generated because people didn't change their filter. So they designed a motor that really allowed people to keep dirty filters in for a longer time. The ECM motor will give you the ability to add this extra filtration that I'm talking about. Look at putting in UV lights. Look at putting in humidification and dehumidification in the spaces. And then more importantly, look at improving the airflow. Like I said, if I could change the way the air moves across the room, I can control the way the virus moves. Next slide. Some of the things that we've done for improvements, which I see a lot of people already have them, sneeze guards. But now we're going to be talking a little bit about elevators. And Bob's going to dwell more on this in the future slides here. Just remember that one, concentrate on MERV 13 filters. You'll use UV lights to try to control it. You need to look at the amount of air changes that goes through the room. And all you have to do is calculate the volume of the room and use the CFMs to determine the air changes. Look at voice activated buttons to control. Give me floor 1 or give me floor 17. So people are not touching buttons. If you have carpet in any of your elevators, tear it out and put in hardwood floors. And use a disinfecting mop to clean the floor so that the droplets are picked up. Airflow across that room should be from, it would be nice in the elevator cab if it was from the bottom to the top, because the distance from my breathing level to my feet is shorter from my mouth to the ceiling than it is from my breathing level to the floor. Now I'll turn it over to Bob.
Thank you, Charles, for that great information. Much appreciated. So, and I'm sure there's going to be some questions. We'll have some questions, and we're going to hold those questions till the end. I just have a very short presentation. I'm Bob Mitchell with Worth Ross Management. In my presentation, it's going to talk about devices and appliances that we discovered during our UV light study during a task force. We're not recommending any of the devices that's going to be on these slides, but they're simply examples of devices and appliances that are available in the market that disinfect the air and surfaces through either filtration or also maybe a combination of UV light application. Your preferred HVAC contractor and your lighting contractor may have the devices and appliances that meet the needs of your association. Also, your engineering firms will have those devices. Also, your preferred elevator contractor will also be able to provide information on the cab disinfection systems that they provide. I want to thank my task force for the job that they did and all the information that they've provided and their time and effort for also providing the information in this presentation. So Jay Williams, the GM at 200 Patterson in San Antonio, thank you, Jay. Carl Hedrick, the GM at the Park Plaza in Dallas, thanks, Carl. And Scott Stringfellow, the Chief Engineer down at the Independent in Austin. Thanks, Scott. So during our study, we discovered numerous devices that, number one, disinfect the air and surfaces in common areas, and then the filter and disinfect the air and surfaces in elevators, and then filter, treat, and disinfect the air in HVAC systems. So when we talked about common area, we looked at front desk, restrooms, lobbies, conference rooms, fitness centers. That's a big one. When we talked about elevators, we looked at elevator cabs, shafts, buttons, railings, and interior surfaces. And then when we looked at HVAC systems, air handling systems, we looked at cooling towers, cooling coils, HVAC systems, air circulation, distribution, and ventilation. So the first slide is an example of one of our air scrubbers that can be used in a common area. This particular one's a Carrier OptiClean negative air machine. The negative air pressure actually pulls in the air from the outside, not the other way around. But it doesn't have to be used that way. It can be used as an air scrubber in the room, pulling in the air and disinfecting that air. It disinfects the air up to 99.97%, as small as 0.3 microns. The cost of that system is about $4,500. It's on wheels and it can move to any room. The second air scrubber that we found was from Medify Air. This unit, it cleans the air 1,300 square foot room in 1 hour. But the cost is only about $275, and it does use HEPA filters. The other unit from Medify Air is a larger unit that covers 5,000 square feet every hour, uses a twin set of H13 HEPA filters, and removes 99.9% down to 0.1 microns. Cost of that unit is about $500. The Broadway in San Antonio ordered 2 of those units, one for the fitness center and one for their media lounge. There's also a nanoseptic system, which is a self-cleaning surface, and it's used to put a cover over elevator buttons or anything high-touch areas. For about $50, you can get a sheet that has 25 buttons, and 200 Patterson currently uses this program. Also, nanoseptic has handle wraps, push bars, and push pads. The cost of this is about $10 And I think Patterson also uses that one. Sterile air distributors in Dallas and in Austin. We reached out to Grant Moreland with Air Equipment Services, AES. Some of the devices that they have, sterile air, they have this system called the RIDS system. It's Remedial In-Room Decontamination System. You can roll it to any room, and it improves the surface disinfection, the air disinfection, and reduces cross-contamination. This can be rolled into like the fitness centers, meeting rooms, or even an elevator at night. It can't be rolled in where people are present. The cost of this unit is $33.78, and it can be delivered in 8 to 10 weeks. The next item is a handheld sterilizer to reach hard to find places and surfaces. This one cost is $523 and can be ordered and delivered 8 to 10 weeks. Other devices that Sterile Air has are HVAC coil and Airstream solutions, in-store and handheld devices, and UVC for disinfection. Now let's talk about the cabs of elevators. First item is the Sterilift from CEC Elevator Cab Corp. This is actually mounted right on the roof of the cab. This technology is forced air. They use double MERV 13 filters. They also hit the air with a UVC source. The clean air is then circulated back into the cab, and it's circulated and changed out once a minute. That's 60 times an hour. That's clean air in an elevator cab. The price is $42.50, $18.75 to install it, so it's about $6 grand. And here's what's included in it. Remember that all this information is available to the managers on SharePoint. They'll be able to access all this information for future needs. So Kone also has their own system. The Kone system is called the Health and Wellbeing. It's a 3-stage system where it sucks air into a sanitation chamber, goes through a MERV 13 filter, is hit with a UVC light, and then the sanitized air flows back into the elevator. Kone, we reached out to them. The price of that is about $89.50, and it requires 1 unit per cab. Disinfection, they have their own air sanitizing system. This is the original one they first came out with. It blows purified air into the cab with a UVC filter, disinfectant, and also a HEPA filter. The cost of this is about $5,000, and it comes with spare sets. They also just revealed, the sales manager from the San Antonio area called me this afternoon, Corey Holmes, and he let us know that they have 2 new systems that they just came out with. One is a GPS solution system for $3,500 installed. The other is a Casper solution system for $3,300 installed. So that information is available on ThyssenKrupp.com. We also have some HVAC applications. This is from dustfree.com. They have a light stick that filters the air in coils, drain pans, and duct surfaces. They've got a smaller one for a smaller footprint. They've got a large one for a rooftop unit. They have a very big one for the extra large applications. Extra large applications would be for coil systems in mechanical rooms, scud units, and the larger RTU units. They also have an air purification system for a unit. This is an example of the larger units for air disinfection. This is for the smaller units, and this is the sample of the air purification for a unit. So next steps, what we'd like to do is we recommend that each association forms either a study group or a committee, and so you can look at your needs, identify your mechanicals, equipment, and the special needs of your association, identify the areas of the most immediate concern of continuous disinfection, and that's probably the elevator cabs, fitness centers, and restrooms. Search and select the devices and products that are needed to address sterilization in your association. And then identify which devices or products that may be purchased, if any. Please pay close attention to the life expectancy of the bulbs and the service requirements for each device. Once you decide on an order and you want to order product, please send that order to me. That's bob@worthross.com, so that I can negotiate with that supplier and use the power of Worthross management to drive a lower cost for each unit, for each association. So thank you for joining that webinar. And now we'd like to open it up to questions.
Thank you, Charles and Bob. And we will circulate this PowerPoint afterwards, and Nicole will, so they will have your contact information there too, in case you didn't capture Bob or Charles' information as they were going through. So some of these questions were answered throughout the course of your presentation. I'm going to ask them again, just in case they were lost in and amongst the presentation. So the first one we have is, are there any lighting or energy incentives to install the UV, the light fixtures? And most of these are probably going to be aimed towards Charles. So Charles, if you want to answer, go right ahead.
There's really no incentive. There is an incentive that has come out under the CARES Act, that if you were a commercial building, you get 100% write-off in 1 year with the purchase, rather than depreciating it over a period of time. They do not mention anything about residential in that particular act. That was the act that came out with the government.
Okay.
So, other than just health improvements, there's nothing to really offer you from that standpoint.
Okay. So this next question is related to filters, the MERV 13 specifically. Is there an available formula to determine if an existing HVAC unit can handle a more effective filter resistance?
What you probably have to do is get with your HVAC contractor on each application, let him look at each unit and see what it is. Sometimes you can actually pick up the phone and call the manufacturer. So then in the case of one building here in town, the homeowner called the factory, which would happen to be Climate Master. They had water source heat pumps, and they said, yeah, there'd be no problem putting them in that particular model number because they had the ECM motor. I'm going to tell you, on most 3-speed motors, I wouldn't even think about it.
Okay. Right. So on the topic of filters, another question, does a MERV 13 filter catch all of the viruses and bacteria?
That's what they say.
Okay.
And actually, if you could go to a MERV 14, it actually does a little bit better job.
Okay.
Or a double 13.
No.
Okay.
Now there's some new filters that's coming on the market that I just saw here recently, but they're going to cost like $150. And you know, that gets to be a little bit high priced, if you want to know what I think. I can buy a MERV 13 filter for around $5 or $6, and easy to put it in. You know, spend $150 and realize I may have to replace it at the end of 2 or 3 months. Gets to be a little bit pricey.
So the life expectancy is the same even on a higher priced filter, 3 months?
It actually deals with how dirty the environment is and how much it filters and collects, because as it starts to do its job to filter the air, the pressure drop builds up. When you get to the point that you can't get any air movement, you're going to have to replace the filter.
Right.
Typically, so, 2 months. 2 months would work with most filters, I'll tell you that.
Okay. In terms of replacement, is it best practices now? Do you recommend or suggest that the person or persons changing the filter wear PPE and filter, put the filter in a bag before disposal?
Yes, sir. Remember, if you're using the MERV 13, you're collecting the virus. Okay. It can live up to 3 days on the surface of that, and the guy needs to be protected.
Okay. So that was it on filters. So we're going to change gears here for a minute. So are there products available for both individual condo owner let me reread this. So are there products available for both individual condo owner units, like the specific units that don't share common area ductwork? So if a unit is just kind of has their own individual ductwork.
Okay, so all the products and advice that we're offering tonight will work with your common areas. It will also work with the individual homeowner.
Okay.
Remember, sometimes when you get into this, example would I do MERV 13 and also ultraviolet lights? Well, it's sort of like a double kill. Do I gain that much more effectiveness? I'd have to really think about that.
Okay. The next question is, what are the most affordable and effective options to reduce airborne transmission of COVID in communal spaces without ventilation?
Filters.
Okay. How long does the air have to be exposed to the UV light in order to kill a virus or bacteria?
All right, the air has to stay in contact with the light for a quarter of a second. And that's why sometimes, that's when I said, if you have, say, a 12 by 12 duct and you're moving the air through it at 1,000 feet per minute, we have to make it a 2 by 2 square duct and reduce the velocity to around 500 feet per minute. If not, you're not going to maintain. If I move it across there too fast, you're just putting something in and you're just paying for something that ain't going to do any good.
Okay.
It's going to be a quarter second and the air has to slow up.
Okay. Bob, this one might be for you, but Charles, you can chime in as well. So Bob, you had explained, or I'm sorry, you showed a few products that can go in an elevator. I assume those have some sort of filtration. So the question is, how do they have filters, those devices, and how frequently would they need to be changed?
Well, yes, everything that I showed for the cabs, they really they're installed right on top of the cab. They have a duct that pulls the air into that. They run through a double MERV 13 filter system, and then they're exposed to UV light for the sanitation and disinfection of the air. And that changes the air out once a minute. So it depends on how much debris is in the air, and they need to be checked on a periodic basis. I would check the first one at a month, and if it's a good shape, I would probably leave it 2 months and then change it.
Okay. And that would be the elevator service. This is expanding on that question. The elevator service provider contractor would do that work, or would that be an in-house task?
Well, I think that each association probably should reach out to their elevator contractor.
Okay.
Because if you have an outside contractor, you may pay not only the outside contractor, but you may have to pull your elevator contractor in to stop the cab, have access to the cab, all those things. So work with your preferred elevator contractor first. If they do the installation, then of course they'll do the change.
Okay. The next question, the next two questions, and that might take us to time. They're both related to to UV. So, what can you explain in layman's terms what exactly UV is, and why it is a means of killing organisms? Like, how does that actually work? What it is and how it works? That's for Charles.
Okay, it's an ultraviolet light that has the ability to kill it. We've been using these in operating rooms for years, and that's one of the means of control that they have. And typically they will use in the room lighting around the perimeter of it to control any disease that's in there. But also in an operating room, if we look at, and that's what we're partly driving for, is they have UV lighting. They have 25 air changes per hour. They use HEPA filters. So they're just doubling up, and it deals with, one, if you're laying on the operating table and you're cut open, you want to have no risk of any disease getting in that person. The optimum range for UV lighting happens to be around 265 nms, light that's out there. Remember, it will affect your light or your eyes. You cannot look into it without using special glasses. If you service these things, be sure you turn them off before you go in to work on them. I think it's important that you realize a couple of things that Bob and I are both talking about. Remember that UV lighting is probably only going to last 1 to 2 years maximum before you have to replace the bulb. The filters, Bob said, you know, every other month probably. It'd be really nice if they put that filter in the ceiling so that our maintenance people could get to that filter by removing an access panel.
So that you mentioned something that is a great segue into the next question, and it is, so you said that the UV light needs to be changed every 1 to 2 years, but is there a way to tell if it's no longer effective, that it may need to be changed sooner, or you have a longer life expectancy?
Well, first off, when the bulb sort of, as any light, as it tends to depreciate its life, it gets dimmer and dimmer. And the thing of it is, it's the same way with these things. Now, you can measure the power that's going to these UV lighting, and you'll see as the life expectancy goes down when to change it. I don't know that they have that made into a handheld device yet.
Okay. Can in an association setting, can the UV light installation or needs, can it be overdone? Like, is there a point where you have too much, like, overexposure?
I think you probably could. I mean, it's, like I said, it's a matter of first, how much can we afford to do? And to some degree, when it comes to our life, how much can we afford not to do? But, you know, if you sort of look at the order of things, filtration is something that's not going to cost you a lot of money if you can do it.
Okay.
UV lighting, if I could get it into the airstream and distributed it, I think that would be real important. Remember that some of the slides Bob showed, we talked about UV lighting, and we had one slide that showed air purification. Big difference between those two devices. One of them with the UV lighting is to control the disease or bacteria that's in there. The one for air purification is just to make the room smell better.
Got it. So we are at time. It is 5:59, so we have 1 minute left. Charles or Bob, is there anything else that you would like to add before we sign off?
Charles?
Really can't think of anything. I think pretty much everything's been covered. You know, I guess the important thing is, and Bob said this, and we've said this time and time again, we do not have one box that we can send you. There's not a box sitting here that either one of us can send and say, go use this box for your building. What we've got to do is you're probably going to have to set up a course inside each building and determine the things that you can do and the order that you do them.
Yeah.
I would say probably from my standpoint, the most important thing to look at this point would be the air disinfection in elevators. That's where the majority of the residents are. That's probably the highest risk area in every association that has an elevator. So that's what my recommendation would be.
Well, thank you both. Charles, thanks for joining us this evening. Bob, thank you for chairing the task force committee, and make sure if your team members, Jay, Scott, and Carl are not on the call, thank them for us. Their contributions were very much appreciated. And with that, we're going to end it, and we will see you all next month. Thanks, everybody.
Thank you.